Hi, it's Zoe Brooks here on December 1st, 2014. I want to introduce you to Quality OptimiZer, a new software, a new process to convert quality control in medical labs to risk management. It's not a new daily QC program, it's not peer QC, it's not proficiency testing, it optimizes all of these. Quality OptimiZer creates a managed system to control laboratory risk. You cannot control lab quality. You cannot control the reagent lot that the manufacturer sends you. You cannot control when the piece inside the instrument is going to wear out. But you can control risk. You can absolutely positively set risk values and manage your system to make sure those acceptable risk levels are never exceeded. I believe. We'll find out. So controlling lab quality is controlling patient risk. It starts with the question, what are your medical goals? What's good enough for your patients? The next question is, how many results are you willing to allow to fail those goals? A number, not a percentage. How many individual people with names are you willing to send medically invalid results to before you stop? And then what are your risk-based quality grades? Quality OptimiZer creates risk metrics that everybody can understand. What is the risk of medically invalid results? Patients can get the wrong diagnosis. Patients can have a delayed diagnosis. They can get an inappropriate treatment, and in rare circumstances, it can even lead to death. For the institution, it means complaints, it means costs, it means failure of proficiency programs, litigation from patients, or even the loss of your license to operate. The risk of medically invalid results is very real. That is exactly why we do quality control. What is the medical goal? The medical goal is the amount, so the absolute amount of error that you will tolerate before you stop reporting and fix the method is the amount of error that can be tolerated without invalidating the medical usefulness of the analytical result. That, I believe, is the traditional, the original definition, and certainly it makes sense. Medical lab results should be medically useful. Effective QC processes protect patients from risk. So if your lab results are good and the QC says they are good, then there's really no risk to the patients. If the results produced are good and the QC says they're bad, there will be a delay, but there's minimal risk to the patients. If the results are bad and the QC says they're bad, again, there's minimal risk to the patients because you've caught that error. You're not going to report bad results. But if the results are bad and the QC says they're good, this is ineffective quality control, then the risk to the patients is high. Can that happen? That's the question we're asking. So the effectiveness of the QC process drives the number of runs before detecting a clinically significant shift. That drives the number of patients exposed to risk in those runs, which determines the number of patients who actually receive medically invalid results, and that determines the clinical cost of diagnostic treatment and errors. So there is a clinical cost, there is a cost of failure to control quality associated with MedLab QC. If clinically significant errors are reported, if your QC fails, if your QC is ineffective, then doctors make the wrong clinical decisions, patients suffer, and your costs and risks go up. It's a bad thing. Quality OptimiZer takes all the confusing statistics and converts everything into a risk-based quality grade that everybody can understand. A grade A has acceptable patient risk. There are no more than the maximum acceptable number of patients exceeding the medical goals specified by the lab director, and you're not wasting time and money on false positives in the lab. A grade B has acceptable patient risk, But the lab's wasting time and effort on false positives. That brings two dangers. You're not only wasting money, but you're wasting effort, you're wasting focus. You want every speck of focus in the lab to go to the real positives, the real times that patients are at risk. A grade C has an unacceptable risk level if the method fails. So the results you're producing now are acceptable, but if the method failed, you would produce an unacceptable number of results before you stopped. All you need to do is to improve your quality control process. A grade D has an unacceptable risk. You're still not reporting bad results now, but the only way that you can ensure an acceptable risk level is to improve your method quality. So a grade D has a poor analytical process quality. It has a very low margin for error. Just improving the QC process is not going to make that method better. You need to be aware of which methods they are, and you need to take action to improve them. And a grade F means a fail. It fails your medical goals right now, and you need to stop. We're going to see some of each of these grades in real examples. What Quality OptimiZer does for you, if you're a fan of Deming, and I had the privilege of hearing the man speak one time, is it lets us manage what we cannot control. You cannot control quality, but you can manage risk. And we can create a system. We can create everybody in the organization working towards one specified medical goal, and the number of patients that you're willing to see exceed that goal before you stop and say, this is not good enough for my patients. We can create that using Quality OptimiZer. So at the level of the lab director, you're going to set what is the allowable error limit? What is the medical goal? The administrators and CFOs want to make sure that those goals are met to ensure the reputation, and they want to ensure that your QC is effective to control costs in the lab, is efficient to control costs in the lab, but more importantly, that it's effective to maintain patient risk levels and eliminate any unnecessary clinical costs. Good QC eliminates unnecessary clinical cost. That's worth mentioning. That's why we do QC. If you don't do QC, you have clinical costs, risks, patient harm. We do QC to prevent that harm to all of the patients that we test. We can actually put numbers around that. What percent of patients would you protect if this method failed with your QC? The lab manager who designs the QC processes can use that risk-based grade and the software reports to set their QC processes. For the working managers, it helps them solve problems and speeds up that monthly review. You get a report card where you can see your entire department on one grade, so you can focus in immediately on any methods that need attention. And for the front line, it takes all those confusing statistics away. It lets you punch numbers into this, and it tells you to improve precision. Where the world will be better off is when we have educators teaching this and manufacturers building it into their programs. It's going to produce quality metrics that everyone can understand. Maximize the patient benefit and care, mitigate the risks, etc. I'm not going to go over all of this. You've read it, we've just spoken about it, and let's see it in action. Let me see the proof of the pudding.